What's that? You want to do some factoring? All right, well, I got some more for you right here. We're going to do some 9.5 notes. This is our last section in chapter 9. This is nothing new exactly. We're just kind of mixing everything that we've done together. So that's why this section is called mixed factoring. All right, so here we go, mixed factoring. So we know how to like factor out the greatest common factor. If they tell us that, we're going to look at each term, figure out what they all have in common. These all have a 3 in common for their coefficient, and then for the x's, the greatest number of x's they all have is an x squared. So if we factor that out, then we get this. And you can double check this by redistributing your 3x squared to each of the terms that you just got. This is what we did in section 9.2. Now, we also did things that look like this. Factor into two binomials. We know how to do this. We are looking for a product of binomials that when we multiply, we get this quadratic. And sure enough, we get x plus 11 and x minus 4 because our factors of negative 44. Ow, my cat. Ow! The cat just jumped on me. I'm sorry, guys. But 44, we don't have a lot of factors. That was really painful. We can do 11 times 4, and that's about it. So the 11 needs to be positive. The 4 needs to be negative. All right, but the issue is, what if they just tell us to factor, right? So they don't tell us if we should take out the greatest common factor, make a product of binomials or anything. So here's the steps that we need to do. If they just tell us to factor, we have 2 steps. So step 1, you're going to figure out if there is a greatest common factor. If there is, then you're going to factor that out first. Step 2, you're going to factor what you have left if you can. All right, so pause the video here. I'm not going to sit here and wait for 30 seconds. Write this down into your notes, please. Hopefully you did. All right, moving on. Okay, so example 1, we need to factor. So we're going to follow those 2 steps that we just talked about. Step 1, we're going to factor out the greatest common factor if there is one, and then step 2, we're going to factor further if we can. So do you see a greatest common factor here? Hopefully you do. Looking at the constants, I see that they all can be divided by 2. And then I also see that each factor has a y in it. So my greatest common factor here is 2y. So I'm going to start by factoring out a 2y. And boom, there we go. So after I have my 2y factored out, I have this trinomial inside the parentheses. Now step 2 said, hey, if you can, now you should factor into a product of binomials. So this trinomial I have, can I factor that? Yes, absolutely. In fact, we just did it all the way over here on this slide. It's the same thing, x squared plus 7x minus 44. What a coincidence. So we're going to go ahead and we're going to factor this even further. So I still have my 2y out front. So it's still 2y. But then that black thing is going to turn into 2 binomials. Like so. So the cool thing is, if we wanted to check this, we have 3 things that we're multiplying together here. So we have a 2y, we have an x plus 11, and we have an x minus 4. If you wanted to check that this multiplies out to give you the original, you can do this in any order. So you could start by multiplying these 2 and do your box method. You could start by multiplying these 2 and simply distribute your 2y. And then after that, you have a binomial times a binomial and do your box method. So whichever order you go in, it's going to give you this original one back. So that's kind of fun. All right, what if we have one that looks like this? It just tells us to factor. So we're going to do the same thing as before. Do you see a greatest common factor here? Yeah, absolutely. Every single one of these can be divided by 9. And then the greatest number of k's we have is k to the power 5. So I'm going to factor out a 9k to the power of 5. And after I do that, the remaining polynomial is going to be, well, I just have k squared left here. This is plus 4k. And then this one is just plus 4. Can I factor the remaining polynomial? Can I factor k squared plus 4k plus 4? Absolutely, I can. I can turn that into k plus 2 times k plus 2, but oh no, there's one more thing I could do. What's the last thing I should do to make this look even nicer? That's right, because k plus 2 times k plus 2 is really just k plus 2 squared. So my end result is this, 9k to the power of 5, ooh, I'm just writing all over the place, times k plus 2 squared. Okay, let's try another one. Okay, we got to factor this. So first, look for your greatest common factor. Well, with the constants, I have a 5 and a 7. Those are both prime, so there's no constant. But they definitely both have an n in them, so I can factor out an n. And after I do that, this is going to be 5n, and this is plus 7. Okay, so now I'm looking to see if I can factor the remaining polynomial any further. I definitely can't because this isn't a quadratic. I can't factor into two binomials. So this is as far as we can go for this one. So yay, we're done. No more further steps. Let's look at example 4. So on this one, is there a greatest common factor that I can factor out? So looking at the constants, 2, 5, and 3, hey, all of those are prime, so definitely nothing to factor out. All right, so instead, I need to factor this into a product of binomials. So remember, this one's a little bit different because this one has a coefficient out front. So this is our a. What's the first thing we need to do with this 2? We need to multiply it to the back. So I'm going to take this 2 and I'm going to multiply it times this 3. And I get x squared plus 5x plus 6. All right, now I'm going to factor this like normal. I'm looking for factors of 6 that add up to 5. Well, that must be 2 and 3, so I have x plus 2 times x plus 3. And then the last step that I need to do, I need to divide back out by that a. So I'm going to divide this by 2, divide this by 2. All right, so after that, anything that turns into an integer does. So this is x plus 1. God bless you.
Thank you.
And then this 2, we're going to multiply it, or we're going to move it to in front of this x. So then we get 2x plus 3. Okay, nothing else I can do there. So we're done with that one. And then last thing we have is example 5. So let's see, do we have any common factors? No, because if it was 9 and 3, we'd be good. We'd have 3, but this 2 ruins it. So nothing I can factor out. Can I factor this into a product of binomials? Well, we could start by multiplying this 9 to the back, but I see that I'm going to have a big issue here. So this is not a squared. This is to the power of 5, and we really haven't talked about how to find products of binomials if you have an exponent greater than a 2 here. So we're just going to kind of use that as our hint to be like, okay, we can't factor this into a product of binomials. So this actually has to stop right here. There's nothing that we can do. This one is just done. It's just dead. So we can't factor. Okay, and so that's a lot less work than we would normally have to do. All right, you have an assignment on Classroom. Go look at what it is. Bye.